to perform the ritual. So we have started. It says here, in the diagram, right, not drawn to scale. Okay, that's very reassuring. They said E is the center of the circle. Oh, wow. And then it
Oh,
says
we do.
L, pardon?
No, carry on.
We're doing, oh, yeah. And then it says laugh, wait, the circle laugh. Wow. L-A-U-G-H. Interesting. The circle is drawn on the Cartesian plane, and then the radius EH bisects the chord LG. Interesting some more. And then it then says here, right? It bisects it at G and at D, and then says the equation of the straight line AG is given in this format. H is a movable point on the circle. So H is a movable point on the circle. Okay, that's interesting. Now the key thing is, anytime you're given an equation of a circle in a format that's not standard, always put it in standard form first. It'll make your life a bit easier. So here we will need to divide by 4 everywhere. So this is going to be 3 over negative 3 over 4x. 42 over 4. Let's see if the calculator can give us something simpler to look at. Or is it going to give us a fraction? Oh, it is going to give us a fraction. But at least a simpler fraction. It's like 10 and a half. So 10 and a half, I mean, like, what does that give us? It's 21 over 2. Might as well put 21 over 2. Okay, fine. Let's see what they want us to do now. They say determine the length of the radius. Okay. Hint, in chapter 8, you will learn that a line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. Yeah. So that's one thing I didn't mention while reading the question because I was holding it back since you haven't learned Euclidean geometry. But here they're telling you up front that in chapter 8, when you will learn Euclidean geometry, one of the laws you're going to learn is that any line from the center of a circle, if it cuts a chord in half, a chord is a line from one point of a circle to the other point.
Okay.
This is a chord, you see. So if the radius or the diameter cuts the chord in half, then it means that it's always going to be cutting it at an angle of 90 degrees. That's a law. So automatically we know this is 90 degrees. Now they're asking for the length of the radius. So getting the length of the radius, you have to remember the length of the radius is just the length from the center until anywhere in the circle. Now your best bet is usually to get some kind of a triangle in your sketch and then use that. But then let's also try and see what information they gave us. Did they give us any other dimensions here? They didn't give us anything. They only gave us the length of E. No. They gave us the coordinates of L and G. So them giving us the dimensions, the coordinates of L and G, I mean, like one way or the other, if we use the distance formula, we can get the length of LG. And then half of LG is just going to be LD or DG if we need it, which you probably do. You see?
Oh, okay.
Yeah.
I see.
Yeah. So, I mean, like looking at this question and looking at the sketch, I mean, like the first thing that comes to mind is it feels as though we're not given enough information. It's just a feeling, you know, because it's like, hey, come on, man. Where is the information? So let's try and read again. In the diagram, not drawn to scale, E is the center of a circle in the Cartesian plane. The radius EH bisects the chord at D. The equation AG has this equation here. And then it says here, H is a movable point on the circle. Determine the length of the radius. So, I mean, like them giving us this hint, I mean, like we have to make use of it, right? We definitely have to make use of it. And the only way I can think of making use of it is by constructing some kind of we don't have to construct a right angle triangle, but let's see what happens if we focus on the right angle triangle that we know is here. This is a right angle triangle.
Yes.
You see? Yeah, that we know. So let's see what else we can do. So we know this is a right angle triangle, and we know that we can get DG if we need to, which we probably will. So we will need to eventually maybe get DG. But then the other question now is, like, this equation of this circle, like, why is it even given? Why is it even useful? So I mean, like, as we're looking at this question, to be honest, like, it definitely seems like there's just too little information, like way too little information. That's just my thought, because, like, what? Yeah, it's not on. So let's see what happens if we had DG. What then? Hi, Bowman. Let's see. In chapter 8, you will learn that a line drawn from the center of a circle is the midpoint of a chord. Yes, it is the midpoint of a chord. And then it is perpendicular to the chord. Yeah, all that is yeah.
Since you say we're going to use the distance formula to find out the length of LG, right?
Mm-hmm.
And then if you have it, we're going to get DG. Is it
Mm-hmm.
possible? I'm just asking, you're curious. Is it
Mm-hmm.
possible to somehow use the Pythagoras theorem?
To get EG.
Yes.
Yeah, that would have worked, but we at least need 2 dimensions, meaning we at least need ED. So that's what I'm saying. With the information given, I mean, like, the straight line, I mean, like, what is the straight line really gonna help us with? That's the interesting question, because it looks like this straight line equation is like, wait, what? Oh, wait. I think we can use the straight line equation to get the coordinate of A. Huh. No, we can't. Ish. That's dumb.
So what's the point of the 4y equals to minus 3 plus 4, 2? Can't it get you the coordinates for A to G?
Well, I mean, like, one way or the other, the equation of the straight line, I mean, yeah, for A, we have nothing. We don't have an X value. We don't have a Y value. For E, we also have nothing. We don't have an X value. We don't have a Y value. For G, we have the X value and the Y value. So yeah, it's just kind of weird. Yeah, I would say this is really, but yeah, this is just a weird question, because it definitely genuinely does feel like there is not enough information, unless it's just something I'm missing, something very blunt, something very obvious. They did say this sketch is not to scale, but then that's not like really gonna do much. If it was to scale, you see, it's really not gonna do anything. In the diagram not drawn to scale, E is the center of the circle drawn on the Cartesian plane. Radius EH bisects the chord LH. At D, the equation of the line AG, and then H is movable on the circle, determine the length of the radius. In chapter 8, blah, blah, blah. Yeah, I think there's something missing in this question. I think you can check what it says at the back of the book before we carry on, like, trying to crack our brains. But who knows? Maybe while you're checking at the back, something will click, because I mean, like, yeah, it does definitely look like something is just off. But then no, yeah, something is off. I'll stick to something is off for now, until the back of the book says something different.
It says the radius is 10.
Says the radius is 10. Well, let's use the distance formula to find out what LG is first. Let's see what LG is. So if you use the distance formula, let's just maybe start working instead of complaining, you know. But anyways, let's see. So let's write out what we can write out based on the information we have. The distance LG is going to be equal to square root of, we can just write 0 minus 14 squared, and then negative 2 minus 0 squared. What is LG? This is going to be negative 14 squared, negative 2 squared. What does this give us in the calculator? I should grab my calculator.
It gives us 10 square root 2.
10 square root 2 is like 14 point something. So let's see,
Yeah.
10 square root 2. Ouch. Oh, my leg. Don't know what I did to my leg. Like, when was it? Wednesday.
Sorry.
Yeah, dude. I don't know what's going on, but and it was like Tuesday. Was it not Tuesday? It was Tuesday. Yeah,
Good thing on Tuesday I also fell. So my
son,
leg is bruised. I don't know what's
sorry,
going on.
madam. Sorry. Maybe there's this bug in the air. It's like, affecting legs. For me, it's like my left leg. Like, ouch. Anyways, so it's 10 square root of 2. So obviously LD and DG is just half of this. So this divided by 2 is just 5 square root of 2. So let's just put 5 square root of 2 here and see what happens. 5 square root of 2. So we have one length here. Oh, no. Still not convinced that there's enough information. Because like we have a 90-degree angle in there. And then we have the length 5 square root of 2. I mean, like if ED is going to be equal to 10, then the radius is equal to 20. But then how do we get the radius of 20 now? See now. I feel like these questions are scams. But to be honest, I do feel like this question, there's not enough information given. Maybe when printing out this question, something was left out, because any question that they ever do ask, the information that you need to answer it needs to be given. We can't like manufacture something from the top of our heads. So I do safely say that unless we want to spend time here trying to come up with what could be missing, I don't think that's going to do us any good. But then I think also, just to be a bit more serious, right, for this question, also just maybe take note of where it is, so that you can also proactively inquire about it whenever it is that you're going to work on it. Maybe there's something that we're missing, or maybe there really is not enough information. But that's something we need to get to the bottom of.
Okay,
You get?
Yeah.
Yeah. Unless you see something. Do you see anything?
Yeah, I really don't see anything. Apart from the fact that I just need to get EG and then I'm done. But
yeah,
OG.
but there's nothing. There's nothing, Iso. There is like absolutely nothing. Like the equation of the circle, it's really not gonna do much. But then let's see. Maybe we are being a bit too lenient on ourselves. So with a circle, right? What we do know about a circle is that a circle is symmetrical. What does that mean now? I don't want to be too. A circle is symmetrical. It means that the coordinate of G, on the other side, we can work out what that coordinate is just by knowing what G is. Because I mean, like, yeah, I feel like G is probably the answer, because from G and A, right, if you look at it nicely, oh no, yeah, it doesn't look like it's working out. Like, yeah, let's just forget about it. Because I was about to say from G, we can try and see what we can try and like figure out. Yeah, because it would have worked if we at least had E, but we don't even have nothing, so it's kind of difficult for us to do anything here. So I think here, let's just say, pardon?
Is it possible to use what is this, pi to solve
Hi.
this? I don't know, I'm just thinking outside the box at this point.
Since we have a circle, okay. Like, I get you, pi r squared. Yeah, well, I mean, yeah, we can think whatever we want to think, but it doesn't look like there's enough information for this question. They should have given us something extra, but they didn't, because they're stingy. All they're doing here is making up weird names of circles. Laugh, circle, laugh. What a wow. Y'all could have just used your ink to give us more information, but no. Anyways, let's see what the next question is actually asking. Maybe the next question will give us something to work with, because like, wow, you know. Let me crop this thing here, make this a bit bigger. How was this thing now? You see these weird things? Oh, okay, never mind. It says H is moved in a clockwise direction. So moving it in a clockwise direction means they move it towards the left. You know, H is moved in a clockwise direction, round the circle in such a way that HG is 10 square root of 3. If EG is 10, what a wow. Determine HUG, the angle HUG. What a wow again. Yo, yeah, these questions, they're being extra, eh? So what I mean is, if H was moved somewhere here, right, you would have the new, what you may call, technically your sketch would have U up there still, but then H would be here, and then the H will be here. So angle HUG is this angle over here. So they say that the distance between G and H is just gonna be 10 square root of 3, 10 square root of 3. Now they want us to work out this angle. Yeah, another scary question. Because now I'm also thinking, wait, what? Oh, so the other thing is that they say you attempt this question after you've studied chapter 8. Yeah, wait, what chapter is this Euclidean geometry in this book?
Chapter 8 is, what is chapter 8? Oh, I don't like chapter 8. I really don't. What is this?
Yeah, don't worry, chapter 8 is going to be
Yeah, it is
friendly once.
Euclidean geometry.
Yeah, so I think with this thing, let's just scrape the whole thing, because I'm like, as you can see, attempt this question after chapter 8. So I'm like, there's really no point in us wanting to learn a whole new chapter for this question, because it's not gonna happen overnight. You see, it's like gang time to like learn it. So let's just move on to bigger and brighter things with our time. Let me just stop this recording also. So do this. So this is proof that some of these IAB textbooks, you see, so not. What is this? Hey, let's not judge unless it's a good reason to be judging.